Section 1.4 is on factoring polynomials. Factoring is a big tool that we'll be using this entire class. So all of our objectives today are different ways that we can factor something depending on what they give us. But you'll notice every single one is going to revolve around this idea of factoring. For those of you that aren't super familiar with it, it's basically breaking something apart so that we can see individual pieces. So let's try the first one. Probably the easiest thing, or the easiest way to go about doing this, and this is the thing you usually want to check for first, is to see if you can take out the greatest common factor, or the biggest thing that both of them have in common. So this first polynomial, I have 18x cubed plus 27x squared. And notice, let's look at the numbers first, the 18 and the 27. What is the biggest number that will go into both 18 and 27? It should be a 9. And then I look at the x's. What's the biggest thing I can take out of both the x cubed and the x squared? Well, an x squared. So the greatest common factor is 9x squared because that's the largest thing I can take out of both of these terms. So then in parentheses, I'm going to write what would be left. If I divide a 9x squared out of 18x cubed, I'd have a 2, and then an x squared out of an x cubed, I'd have an x left. Plus, and then if I divided out of the 27x squared, 27 divided by 9, I'd have a 3, and x squared divided by x squared, there wouldn't be any x squareds left. So this entire quantity is the factored form. Down the road in another unit, we'll see the purpose behind factoring. For now, we're just going to get used to it. Okay, the next set. If I look at my two terms, here's one chunk, and here's the other chunk. They're separated by the addition, just like they were on the first one. So if I ask myself, what do they have in common? Well, they both have x plus 3. That's the greatest common factor. So we're going to set that out front, just like we did with the 9x squared. And then behind it, I want to write what's left. So this first chunk, if I took an x plus 3 out, the x squared is left. That was out front. Plus, the back set, if I took the x plus 3 out, I have the 5 left. So this entire thing is the factored form. By the way, there's multiplication in between them when they're written next to each other like that. But you don't have to write the multiplication. All right. The next way to factor something besides the greatest common factor is by grouping. Now, usually you'll only mess with grouping if there are 4 terms. So on this first one, notice I have 1 term, 2, 3, 4. They're separated by the addition. So there are 4 terms. So we're going to factor by grouping. So what you do is I want you to group the first 2, and I want you to group the second 2. So we're essentially making 2 groups. Now from the first group, we're going to take out the GCF, the greatest common factor. So from the first group, what's the biggest thing that I could remove from the x cubed and the 4x squared? I could take an x squared from both. And then I want to write what's left. So if I take an x squared out of the x cubed, I still have an x. And if I take it out of the 4x squared, I have a 4 because I divided out the x squared. And I have my addition. Now let's do the blue group. What is the greatest common factor that I can take out of the blue group? The biggest thing I can take from 3x and the 12, I could take and divide out a 3 from both. So if I write what's left, I'd have an x plus 4 left. Now when you're grouping, you'll know you've done it right if the inside portions end up being exactly the same. That's how you know you're on the right track. So the last step, here's one chunk, here's the other chunk. What do they both have in common? Well, they have the x plus 4's in common. So I can factor that out. And in the other group, I'll write what's left. So from this first group, if I took the x plus 4 out, I have the x squared. From the second group, I have the 3. This is the factored form. Okay, so let's try a next one here. I have 4 terms, so I'm going to group. That's how you know you're going to group, if you have 4 terms. Here's my first group. Now with the second group, I want to make sure that negative is with the 2. So from the first group, GCF, what is the greatest common factor I can take out of this blue group? Well, it looks like I can take a 5 out and an x squared. So I want to write what's left. A 5x squared divided out of a 5x cubed, I'd have a 1x. And a 5x squared divided out of 25x squared, I'd have a 5. Now let's look at the red group. What can I take out of the red group, the greatest common factor? Well, it looks like I can take a negative 2 out. So if I divide a negative 2 out of negative 2x, I now have a positive x, and a negative 2 out of negative 10, I would now have a positive 5. Notice I know I've done it right because the inside groups are exactly the same. So from my first chunk and my second chunk, what do they have in common? They have the x plus 5's in common. So if I factor that out, what would be left? Well, from the first group, there'd be the 5x squared, and the back group, there'd be the minus 2. There is the factored form. The other way to factor is factoring trinomials. Trinomials, let the word tri kind of tell you what you're dealing with. A trinomial is a polynomial with 3 terms. So it might be something like 3x squared minus 2x plus 5, or x squared plus 8x plus 1. 3 terms. So grouping won't work because I don't have 4 terms. Now, depending on what you learned in your last math class or in high school, a lot of people will use trial and error to factor these, and that's the way I learned it. But since then, I've learned of a little bit better way that in my past years of teaching, people that have struggled with factoring don't struggle when they use this way. So you're more than welcome, if you already know how to factor and you like the guess and check way, you're more than welcome to do that. But I also want to show you this other way. Whoops, jumped a page on me here. So this other way, it's referred to as marfing. Yeah, it's a lovely word, marf. And what it stands for, it's a way to factor trinomials. So the M stands for multiply. The A stands for add. The R stands for rewrite. And the F stands for factor. And when my students do this, they make this little crisscross. And in this crisscross, in the top portion is going to be what you multiply to, and the bottom portion is going to be what you add to. And I promise this will make a little more sense when we go through this. So let's try this. I want to break apart x squared plus 6x plus 8. So what my students will do is they'll make a little crisscross. And for the top part, the multiply part, you're going to take the very front number and the very end number and multiply them together. So 1 times 8, we're going to put an 8. That's what I want to multiply to. For the add number, it's the number in the middle, 6. So now it's a little game. You have to ask yourself, what 2 numbers multiply to 8 but add to 6? multiply to 8 but add to a positive 6. And hopefully you think, let me do it in this color. Hopefully you think, oh, 2 and 4. Or you can, the order doesn't matter, 4 and 2 or 2 and 4. So all we do now is we are going to rewrite this. So I'm going to replace this middle term with the two numbers that I just found, 2x and 4x. Notice the front and the last stay the same. I have just rewritten the middle with the two numbers I found. If you can get it from there, now it's just grouping because I have 4 terms. So from the first group and from the second group, it's just like what we were doing. From the first group, what do they have in common? Oh, I could take an x out. From the second group, what do they have in common? Oh, a 4. Notice my two sets match. So I can take the x plus 2 out, and I would have x plus 4 left. There is the factored form. So those of you that know trial and error, yes, this is more work, but when they get harder, this way will always work as well. I don't care what way you take. So the next one, let's see if we can factor this. So I want to multiply, I'm going to take my front number and my back number, 1 times negative 14. I want to multiply to a negative 14, and I want to add to a negative 5, my middle number. So you have to ask yourself, two numbers that multiply to negative 14 but add to negative 5. Should be negative 7 and a positive 2. So now rewrite it. X squared minus 7x plus 2x minus 14. Again, the first and last number don't change. It's the middle two that I'm rewriting. And now I'm going to factor it by grouping. So we'd get x minus 7 and x plus 2. You may have noticed that factoring is the exact opposite of foiling. If you really wanted to check your answer, if you thought, man, I don't know if I did this right, if you FOIL it back together, so first times first would be x squared, outer times outer would be 2x, inner times inner would be negative 7x, and last times last would be negative 14. If I combine like terms, notice it's the exact same as what I started out with. That's the way you can double check your answer if you don't think you factored it right. We're breaking it back apart. Okay, I'm going to erase just to give myself some room to do this last one. So on this one, I want to multiply 1 times 9. I want to multiply to 9, but I want to add to 6. What two numbers multiply to 9 but add to 6? Should be 3 and 3. So let's rewrite it. Again, the first and last numbers don't change. It's the middle numbers that I'm rewriting. And now factor by grouping. Taking the GCF out of each group. Now something funky happens on this one. After grouping, I get the exact same quantity. If that happens, an even cleaner way that I would prefer you to write the answer, we're going to write it once with a squared because it was the same exact thing. All right, this is where, notice this time the leading coefficient, this number in front, is not 1 anymore. This is where the morphing trick really helps my previous students. So I want to multiply 3 times 14 would be 42. And I want to add, make sure it's a negative 13. So we're going to have to take a moment. What two numbers multiply to positive 42 but add to negative 13? You should come up with a negative 7 and a negative 6. So let's rewrite it. 3x squared minus 7x minus 6x plus 14. Again, the first and last do not change. It's the middle set I'm rewriting. And now let's group. Make sure to keep that negative with the 6. So from the first group, I could take, I think, just an x. Now, we have to be a little bit smart here. In the back group, what can I take out? And you might say, oh, the biggest number that comes out of them is 2. I actually want to take a negative 2 out, because by doing that, then they'll both be 3x minus 7. So to finish it, if I pull the 3x minus 7 off of both, I'll have an x and a minus 2 left. There is the factored form. By the way, that is the same thing as if you had this. The order doesn't matter to me because they're multiplied. I don't care which way you write it. Okay, next one. Even though these are y's, it works the same way. So if we marf it, I'm going to multiply, so 8 times negative 15. 8 times negative 15. Ooh, that's a negative 120. And I want to add to 14. So they have to multiply to negative 120, but add to a positive 14. Now, it might take you a little bit to figure out the two numbers, but I'm going to tell you it's a positive 20 and a negative 6. They multiply to negative 120, but they add to 14. So let's rewrite it. Again, the first and last numbers don't change. It's the middle set I'm rewriting. And now we're going to group. So what is the GCF from the first group, the greatest factor? Well, I can definitely take a y and a 4. So I would really like to see a 2y plus 5 in this other group. So I would have to take out, the biggest thing I can take out is 3, but I want to do a negative 3. So I end up with 2y plus 5 and 4y minus 3. That is the factored form. Okay, next one. Oh my gosh, now they have x's and y's. Well, guess what? Marfing still works. We'll do it the exact same way. Not going to let it throw us off here. So I want to multiply 2 times 3, 6. I want to add to negative 7. So I need two numbers that multiply to 6 and add to negative 7. Negative 6 times negative 1. So I'm going to rewrite it. 2x squared. The middle set will be a negative 6xy minus 1xy. Again, I leave the first and last. It's the middle that's getting rewritten. Group. So from the first group, I can definitely take a 2 and an x. They both have at least an x. So I'm going to take a 2x. And notice this back set, I'd have 3 and a y. The x is gone. And then this other set, well, they both have a y. And I want it to become x minus 3y. So I'm actually going to have to take a negative y out. Because when I do that, I'll still have a positive 1x and a minus 3y. So now to finish it, I have x minus 3y in one group and 2x minus y in the other group. There is the factored form. Next one. I want to multiply to 8 times negative 3, negative 24. And I want to add to negative 10. So I need two numbers that multiply to negative 24 and add to negative 10. You might say, oh, negative 6 and negative 4. And I would say, not quite. Because negative 6 and negative 4 do add to negative 10, but they don't multiply to a negative 24. I'll tell you, there aren't two numbers that do that add to negative 10, but at the same time multiply to negative 24. So what this means, this problem cannot actually be factored. So you could say it's not factorable. I think on the homework today they're going to ask you to say, they're going to call it it's prime, which means it can't be factored. It's already as simple as it's going to get. So it is possible to have some that don't even work. All right, one more of this type, and this one I put on here because it's kind of a sneak attack. What you should really check for first every time you do these is a greatest common factor. Notice all three of these terms, I can take something out. They all have an x, and I can take a 2 from all of them. So let's do that first. So if I divide out a 2x, this first guy I would still have x squared. The next guy I would have 4x. And the last guy I would have 4. Now, with this portion, let's mark it. So I want to multiply 1 times 4 to 4, and I want to add to 4. So what numbers multiply to 4 but add to 4? It's a 2. So I'm going to rewrite it. I have x squared plus 2x plus 2x plus 4. Keep in mind this 2x out front is still out front. It's just going to carry down with our problem. So if I group this here, from this set I can take an x out. From the other set I'll take a 2 out. This stylus, I tell you what, I'm just carrying down this 2x. So then I get x plus 2 and x plus 2. Since they're the same, we can just write it as x plus 2 squared. So if you factor something out right away, just carry it down. Don't lose it. It's got to stay part of the answer. All right, another way that you can factor something is called the difference of squares. And this is probably the easiest way to factor out of all of them. All it is, all this rule says, difference refers to subtraction. So if you have two items that are both perfect squares being subtracted, that will break apart into a plus b and a minus b. But they have to be perfect squares and there has to be subtraction. So let's try this example. X squared minus 4. Well, x squared is x times x, and 4 is also perfect. It's 2 times 2. So this factors into x and x, 2 and 2, one of each sign. And it's done. The next one, perfect, perfect, and subtraction. So it's going to break into 9x and 9x. It's like you're square rooting. 7 and 7, one of each sign. You could also put the subtraction first and then the addition. It does not matter. Okay, last one. Perfect square, perfect square. So hopefully you're guessing. I wonder if x squared breaks into x and x. How does x to the fourth break? Well, it'd be x squared and x squared. 9 and 9, one of each sign. Now I'll tell you, if you're really good, this is not the final answer because one of these two pieces will factor again. And it's this one because I have a perfect square, and subtraction. So that's going to be x and x, 3 and 3, plus minus, and then keep the x squared plus 9. So that one has 3 pieces to it. And the last thing, the final thing I might throw at you to factor is cubes. So to factor cubes, I have yet another rule that might make it easier. We use the acronym SOAP to help remember this. So you're thinking, geez, all these 4-letter words, MARF, FOIL, SOAP. I know. Hopefully it makes it easier, though. We'll talk about how SOAP comes into play in just a moment. Let's look at the example. X cubed plus 8. So to factor this, before you even break it apart, I want you to think, okay, this first guy is like x cubed, right? X times x times x, plus this other guy is what number times itself 3 times? Hopefully you think, oh, it's 2. Here's all you have to do to break this apart. You're going to have 2 sets of parentheses. In the first set of parentheses, you will have exactly what you have without the cubes. So x and 2. In the back set of parentheses, there's going to be 3 numbers. In the first spot, it's this first guy squared. In the back, the very last spot, it's the last guy squared. So 2 squared, 4. And in the middle spot, it's them times each other. So x times 2, 2x. And the last thing that we need are just the operations, and this is where SOAP comes into play. This is just a way to remember the signs. S stands for same. O stands for opposite. And then the final 2 letters stands for always, plus. So what I mean by this first operation in the very first set of parentheses will be the same sign as what it was in the problem, plus. The next operation will be opposite of that, minus. The final operation is always plus. This is the factored form. Okay, last one. Before we factor, let's think about, I have to know what is being cubed. So what cubed is 64? If you look at your previous notes, we did write down what that perfect cube was. It's 4, so this is a 4x. And same thing for the 125. What cubed is 125? It's a 5. So knowing that, let's set up our parentheses. So in the first set will be the 2 numbers without the cubes, so 4x and 5. I'm going to have 3 spots. And the first spot is the first guy squared. So if I square 4x, that's 16x squared. In the back spot is the last guy squared. So 5 squared, 25. And then the middle spot is them times each other. So 4x times 5, 20x. And now the operations. The first sign is the same as what it was in the problem, subtraction. The next sign is opposite. And the final sign is always plus. There is the factored form. So lots of factoring, but hopefully there's a couple of tricks in here somewhere that helps you out.